Dear students, welcome to today's lecture. In the last lecture, we discussed about the weighted resistor type DAC. In this lecture, we are going to discussing about the R-2R ladder type DAC. We shall see the details. What is the drawback of weighted resistor type DAC? In weighted resistor type DAC, the weight of resistors is ranges from up to 2 raised to n. Suppose if n is the number of bits. So, the use of wide range of resistors is the main drawback of weighted resistor type DAC. This overcome in R-2R ladder type DAC, where only two resistor values are used, that is R and 2R. Only two resistor values R and 2R. Okay. So, we shall see the detailed circuit diagram of R-2R ladder DAC. This is the circuit diagram for R-2R ladder DAC, and this arrangement is for 4-bit DAC. Here we use op-amp. This op-amp is act as a summing amplifier. Okay, and two range of resistors, only R and 2R are used here. The op-amp, the positive terminal is grounded and the negative terminal one feedback resistance is connected, and in negative terminal the arrangement of resistance is very important. So this 2R, that is 2R resistance are connected in parallel and R resistors are connected in series, and at last one 2R resistance is grounded. This is noted, this is very important. And starting is 2R is in parallel, then R, 2R, R, 2R, R, 2R. At the end, 2R resistance is grounded. Suppose if there are n number of bits, then there are n up to B1 to Bn combination. Then that much of 2R resistance is grounded. Okay, this is the practical arrangement of 4-bit DAC, and here this is for MSB bit. First 2R, this 2R is here the MSB, and at the last here is LSB, and this is a switching arrangement, and this switch is connected to ground and also one reference voltage VR. If the bit is 0, the switch is connected to ground. If the bit is 1, the switch is automatically connected to VR. This is the circuit diagram of 4-bit DAC, R-2R DAC. Okay. Let us see the analysis of the circuit to find out the output voltage using some example. First, draw the circuit diagram of R-2R ladder DAC, and the example 1 we use 100. Okay, then you draw the circuit. So this is the circuit diagram, that is the positive terminal is grounded and in minus terminal one RF feedback resistance RF is connected here, and this 2R, first starting with one parallel 2R resistance. This is for MSB bit. This is for MSB bit, and this 100, that is a 3-bit combination. So here 1, and this is 0, this is 0. So there are 3 parallel combination of 2R resistances needed. This 2R for this bit 1, this 2R for bit 2, this 2R for bit 0, and this 2R, then series combination of R, parallel combination of 2R, series combination of R, parallel combination. At the last, one 2R resistance is grounded. This is very important. And the started with the 2R parallel combination also. So the bit 1 means this this 2R resistance is connected to reference voltage VR. Bit 0 means this is connected to ground and this is also connected to ground. Okay, then solve the circuit by using series and parallel combination of resistors. First, this 2R and this 2R resistors, this is grounded and this is a common terminal. So this 2R and 2R is in parallel combination. So 2R parallel 2R. So the resultant resistance is 2R into 2R divided by 2R plus 2R, that is equal to 4R square divided by 4R, that is equal to R. So this 2R and this 2R is parallel combination and this is replaced by the resistance R. Okay, that 2R and 2R is replaced by the resistance R. It is grounded. This is R. Then this R and R, that is in series combination. So the resultant resistance is 2R. So replace this R and R by 2R. That is, this R and R is 2R. That is 2R. This is grounded. Again, this one end of the 2R is connected to this point and the other end is connected to ground. One end is this resistance 2R is this point, one end is grounded. So the resultant resistance of this 2R and 2R combination is again R. These 2R and 2R in parallel, again this is R. Okay, so this is R and one end is grounded. Again this R and R in series, that is 2R. Okay, replace it. Replace it by 2R. This end is grounded. So at last we got one 2R resistance is in ground and another 2R resistance that is connected to VR. ഈ റെസിസ്റ്റൻസിൻ്റെ ഒരു വോൾട്ടേജ് സോഴ്സും ഇവിടെ ഒരു വോൾട്ടേജ് സോഴ്സും ഇവിടെ ഒരു ഗ്രൗണ്ട് ടെർമിനലും ആണല്ലേ. സോ നമുക്ക് ഇങ്ങനെയുള്ള ഒരു അറേഞ്ച്മെൻറ്റ് സോൾവ് ചെയ്യാൻ വേണ്ടി യൂസിങ് തെവെനിൻസ് equivalent circuit. Thevenin equivalent circuit. So first you find out Thevenin equivalent voltage VTH. VTH is, this is VR and this terminal is grounded, and so the voltage VR into VR into 2R divided by 2R plus 2R. This is VTH, that is equal to VR into 2R divided by 4R, that is equal to VR by 2. This is Thevenin equivalent voltage VR by 2. VR by 2. Then you find out RTH. RTH, for that this terminal is, this voltage source is grounded. Then you got this 2R and 2R is parallel. RTH is 2R parallel 2R, that is equal to R. So this is RTH. So in this portion, replace the circuit, replace the arrangement by Thevenin voltage VTH and the Thevenin resistance RTH. Okay. So then we can see another example, that is 0 1 0. So the circuit, you draw the circuit first. So this is the circuit diagram, that is plus terminal is grounded and the minus terminal is connected to RF. This is V out and this is the resistance R. One parallel combination of 2R, that is for bit 1 is equal to 0. So this is connected to ground. Bit 2 is 1, so this is connected to VR. Bit 3 is 0, so this 2R is connected to ground. And last one series 2R resistance is grounded. Again solving, then first we get this 2R and 2R is in parallel combination. So the resultant resistance is R. And this R and this R is in series combination. Then you will get here 2R. So this is 2R, this is grounded, 2R. Then here we apply the Thevenin circuit. So first you find out Thevenin voltage. VTH, that is equal to VR into 2R divided by 4R, that is equal to VR by 2. Then you find out RTH is equal to R. So you will get this Thevenin equivalent resistance is R and VR by 2 is the Thevenin voltage. So this R and R in series, so this is 2R. This combination is 2R. Okay. Then again here we apply the Thevenin circuit. And then you find out VTH. Then VTH is equal to this VR by 2 into 2R divided by 4, 2R plus 2R, 4R. That is equal to VR by 4. And this 2R and 2R, then RTH, that is equal to R. 2R and 2R in parallel, then is equal to R. So again replace this portion. So we get resistance is R and the voltage is VR by 4. Okay. Then V out is equal to minus RF by R into input VR by 4. This is for bit B2. Okay, this is the output voltage. So generally we can write the expression for V out. V out is equal to minus RF by R into VR B1 by 2 plus B2 by 2 square plus etc. Bn by 2 raised to n. This is MSB bit and this is the LSB bit. Okay. This is the expression for V out. This is the expression for R-2R ladder DAC, the analog output voltage V out. Okay. So we get this expression V out is equal to minus VR into RF by R into up to B4, then up to Bn by 2 raised to n. And another two equations, that is the resolution of R-2R ladder DAC with current output and resolution of R-2R ladder DAC with voltage output. For current output, the resolution is weight of an LSB bit. What is the weight of an LSB bit? Weight of an LSB bit is minus VR by RF by R into Bn by 2 raised to n. Nth bit is the LSB bit. So the weight is for 1 by 2 raised to n into, or bit Bn by 2 raised to n into Br by R into RF. This is R-2R ladder type DAC with the voltage output resolution. And for current, I is equal to V by R, so this RF cancelled. Then I is equal to 1 by 2 raised to n into VR by R. This is for the current output resolution of R-2R ladder type DAC. Okay, thank you.